Welcome back. In this video, we are going to be dissecting lesson 4.4 of Chemistry Honors. This is atomic mass versus mass number, which sounds dumb, but there's actually content behind this. So the relative mass is a relative scale based on hydrogen. Hydrogen is the smallest element and is given a value of 1. And as we know, electrons are omitted from the mass equation because the mass of an electron is negligible. This is the format we use. Top left is mass number, bottom left is atomic number, and then on the right is the chemical symbol. So this is of sodium-23 as an example. The mass spectrometer remains the most accurate way for determining atomic weights. A gas sample is introduced in A and bombarded by a stream of high energy electrons at B. Collision between the electrons and the atoms and molecules of the gas produce positively charged particles that are accelerated towards a negatively charged power grid, or negatively charged grid. After particles pass through said grid, they encounter two slits that only allow a now beam of particles to pass. And this is how we determine atomic weights. So there's a way to get the average atomic mass. You have to weight the averages of how often an isotope occurs in nature. You multiply the mass number. You have to convert the percent into decimals, multiply the mass number, add the products, and do not round the final answer. This is actually a little bit of some AP statistics concepts of weighted averages. You probably haven't taken stats, so I'm going to put this in the other direction. If you take stats, just know that this concept should not be totally unfamiliar because this is a chemistry honors concept. It's not exactly shown, but you have the 10 times 0.1978, and then the 11 times 0.8022 rather. And if you get them together, you should get what the average number is. The most abundant isotope of oxygen is oxygen-16 by a landslide. For gold, it's gold-197. We now use the carbon standard with carbon-12 set at 12.00. So the AMU is the mass of 1/12 the mass of carbon-12. Here's why we used carbon. Hydrogen is a gas, so we really can't use it. It has to be a solid. So obviously I asked the question, why can't we use lithium? The answer is because lithium is not commonly found in nature, nor is rubidium or boron. So we are stuck using carbon because carbon is the smallest commonly found solid at STP, that being 273 Kelvin or 0 degrees Celsius or 32 degrees Fahrenheit, and 1 atmosphere, 1,013 kilopascals. So, in this case, for ion, it has an excess positive and negative charge. If there's a positive plus there, you have to subtract that from the amount of protons to get electrons. If there's a minus, you add. I know there's kind of a dearth of coverage in this, but I don't really have that many extrapolations to do. So I think I'm just going to end it here.